Hey Algebra 2, welcome to e-learning. Today what we're going to do is a little bit more with linear and exponential, but this time they're going to involve some word problems. So here are the two equations that we've been working with this week. So for your linear equation, we're basically going to be working with y equals mx plus b that you've used for many years. B is the starting value on a word problem. You're used to that being the y-intercept. And M is the rate of change. You're used to that being your M or your slope. In exponential, we're going to use a times b to the x. Got to remember that a is the starting value, and that was also your y-intercept when we did other problems the other day. And b is going to be the multiplier. That is how much it is going up. All right. So this says that if the growth or decay involves increasing or decreasing by a fixed number, then you are going to use the linear function. What would that look like? It would look like this. If the growth rate or decay is expressed, and then this says if the growth rate is using multiplication, and you see words like doubling or halving, that is going to be your exponential function. All right, let's get into the first one. The library has 8,000 books and is adding 800 more books each year. So this to me looks like a linear kind of problem. So that 8,000, that is going to be my B, because that is my starting number. You're going to add 500 books each year. And up above it says that if you are increasing by a fixed number, I'm going to use a linear. And so that's why I'm going to use y equals mx plus b on this one. So I do have a linear. I'm using y equals mx plus b. Your m is how much you're adding each year, and so that is where your 500 goes in. And then your b is your initial or your starting amount. And so that is how I got the first equation. A gym's customer pays $50 for a membership plus $3 each time they use the gym. All right, so this one is also going to be a linear. That $50 for a membership, that is your starting amount or your flat fee. So if you see anything that looks like a flat fee, that is going to be what your B value is. That's your initial or starting amount. And right here it says plus $3 each time you use it. So it's going to go up by a fixed amount every single time. So that is your M. So once again, I'm using the general form y equals mx plus b. And so it's going to go up $3 each time, so that's a 3x plus 50. Next one says, my bank account starts with $10. All right, so it starts with $10. There's some kind of initial or starting value. Every month, the amount is tripled. So it's not going up by a fixed number, it is tripled, and so if it uses multiplication, because this is multiplication, that means that I have an exponential function now, because it is being multiplied and not added. So I looked up at my table above, and it says that my general form is y equals a times b to the x. And it says a is your starting value. So $10 is my a, that's my starting value. And the b is the multiplier. So therefore, if it's going to triple, that's going to be my b. So when I put it together, I have y equals 10 times 3 to the x. That's how you would do those word problems. When I come to page 2, I'm not going to do these two. I'm going to let you give it a try. Let me clarify and state, this single page is homework for you to upload for your e-learning day. And you're going to upload it to 6-5. That's where it's going to go. And it is just simply this one page. These two are new, and the rest of them are old. That's what we've done for probably 2 days now. I'm going to skip page 3, but we've done a few of these. And I'm going to do a little bit more on the back page. I have a science experiment that involves periodically measuring the number of mold cells on a piece of bread. At the start of the experiment, there are 50 mold cells. All right, so that says that my initial amount is 50. I don't know which one I'm using yet. Each time a periodic observation is made, the number of mold cell triples. Now I do. Now I know that I am using an exponential function because that's being multiplied. So write a function. So I have y equals a times b to the x. This initial amount, that is my a, and then since it is tripling, that means that b equals 3. So write an equation, y equals 50 times 3 to the x. So we would like to fill in the missing values of this table. So when x is 0, it says that y is 50. Does that make sense? I don't know. So I have 50 times 3 to the 0. That's how you would plug this in. I just plugged that in for there. So anything to the 0 is 1, and 50 times 1 equals 50. That checks out. This says when x is 1, your answer should be 150. Okay? So that means I have 50 times 3 to the first power. 3 to the first power is 3, and 3 times 50 is 150. Now it says, plug 2 in for x. So I have 50 times 3 squared. Order of operation says you have to do exponents first, so 3 squared is 9. And 9 times 50 is 450. And I kept repeating this process. 50 times 3 to the third. 3 to the third is 27, and 27 times 50 is 1350. I kept repeating this process. I got 4050 for the next one, and 12,150 for the last one. So this says at your first observation, I had 50 mold. At your third observation, I had 1,350 mold. And at the fifth observation, I had 12,150 mold cells present. When will I have more than 100,000? I don't know. This really isn't too terribly complicated, so I would just keep plugging in bigger and bigger values one by one until I figure it out. And so I said, what happens when x equals 6? I had 50 times 3 to the 6th, and I'm going to do the math real quick because I did it a different way when I did my notes. 3 to the 6 times 50 is 36,450. What happens when x equals 7? 3 to the 7th times 50, and I get 109,350. And so that is bigger than 100,000. On which observation will this happen? The 7th. It says, what will the mold count on the 20th observation be? Wow, that's going to be a big number. 50 times 3 to the 20th. And it says, first you're going to do it in scientific notation. And so in scientific notation, when I did it, I got like 1.74 times 10 to the 11th power. And this I rounded. There were actually a lot of numbers there. But when you have scientific notation, that says take your decimal and you need to move it 11 places to the right. So we move it however many places that exponent is right there. And so when I moved it, I got like, 174, 339, 220, 100. So I got a lot of cells. And we should be able to finish the rest on your own. So give that a try. And please remember to submit your homework by Sunday night. Thank you, and I will see you all on Wednesday. Bye.